So I'm Ben. I've been drinking beer for quite a long time. I've been brewing beer for getting on a decade in my house. I became a fancy accredited beer judge via the BJCP, which is the American Society of Homebrewing Judging, about 6 years ago. And I write software that occasionally works. So that's my background. This is my nightmare. The reason why it's my nightmare is someone tell me how I'm supposed to pick a beer, given this, we'll call it a menu. I mean, that's actually, at least that's a method that is coherent. I have a lot of trouble making decisions when faced with pubs like this. And the sort of alternate is, this is a menu from a very now long defunct pub, Mason and Taylor, one of my favorites, although they've like reborn in Hackney Wick, which is nice. But like the thing I want to sort of draw your attention to in comparison to the first one is that rather than just relying on the sort of brand image of the brewery, if I can make it out, and having to walk about 4 meters to get the whole menu in, I can look at the whole thing at once, and I've got a couple of sentences, and it's sort of semantically clustered in some way. And I can see the ABV, and I can see the price of each thing. So if I wanted to just order the cheapest one, that would even be achievable without having to have a long conversation with the bar staff. So right, so the basic goal of like the things I'm going to talk about is automating the transition from a list of beers that has no real consideration to a coherent, summarized menu. So with that in mind, we're going to talk about document summarization of beer reviews. I should quickly note also that while it says over there that I work at Fun and Plausible and the university called Goldsmiths, that's not true anymore. I now work for a nice company called FutureLearn. That started about a week ago. So just to keep this accurate. So this talk really is about two different things. The first, of course, is beer, and in fact, specifically lots and lots and lots of beer and choice in beer. And the second is just like a general idea of text and piles of text and trying to make sense of piles of text. It's worth noting also that both of those things generalize, so you can take the things that I'm talking about and apply them to radically different fields beyond beer. If you don't, I don't know why you'd want to, but if you don't want to just talk about how beers compares to each other, instead you want to talk about really any other thing that people have had discussions about in volume. And also the particular methods that we're going to sort of treat text with, you can use sort of any streaming data. You can if there are semantic chunks you can make that are analogous to the idea of like words and sentences, you can apply the same stuff we're going to do to audio or chunks of video or whatever you can sort of conceive of in that abstraction of something we could call a word and collections of words we could call sentences. Also, the talk is informal, so there's going to be some like code that defines math, and it's going to be really loose. So I'm hoping this crowd doesn't call me on it. It'll be fine. Okay, so I'm going to kind of skim through this part because I have a suspicion this crowd is pretty good on this, but let's talk a little bit about what makes beer beer, because it's informative for the sort of rest of things. So there's 4 core ingredients in a beer. The first is water. Water is most all of beer, really. The second is malt, which is the seeds of cereal that are tricked into germinating and then killed violently, and then that's malt. And then hops, which are just a very convenient bittering herb that traditionally is the bittering herb for beer, but you could use other things like heather or whatever. You just need to sort of bitter the sugar. And then yeast. And the thing about yeast is that every single drop of water passes through the yeast's digestive tract along with the sugar, and then you get some alcohol. And so the yeast, even though there's not a lot of it involved, and actually there's barely any in the finished product, has a significant and quite meaningful impact on the resulting product. So you have those 4 core ingredients, sometimes other things, but mostly just those 4. And then you have 4 really core steps. You mash. Now mashing is making like a sort of porridge, a loose porridge. And then you drain the liquid off. You take that liquid and you boil it. And when you boil it, that's when you add the hops, the other things, or some of the hops. And then you ferment things. You dump the yeast in, makes a nice bubbly, exciting thing. And then after you're done fermenting it, you might store it and then you package it. And between the ferment and the package is when you add things like dry hop, this sort of thing. So that's the sort of core steps. That's really, and you can wiggle on what happens in the details, and that's how you get every single variety of beer, many of which we have on the table in front of us. So the thing about this is you've got four core ingredients, 4 steps, and just tremendous variety, such that you can have people who devote their lives to sniffing small quantities of beer, writing 3-page reviews of them, and then giving them a score. And so this is a beer judging contest, and because we have the internet, this can happen in the privacy of your own home, and then you can communicate your thoughts and feelings about these beers that you've sniffed and considered and rolled around in your mouth and written lots of words about on the internet. Rate Beer is one of those sites. There are a few others. I like Rate Beer a lot, despite its very straight out of 1998 lamp stack aesthetic. And there's a bunch of reasons why that is, but mostly because it caters to a certain kind of very considered beer nerd, which makes it a really good wealth of data. So if we look at Rate Beer's site just for a moment, so first of all, we'll just take a minute to really love their CSS choices. But the thing that I want to sort of draw your attention to is a couple of points. So this is a pretty sort of standard, top-level metadata collection for each beer. This is Brewdog Punk IPA. They're specifying in the name as a hack that this is the 5.6% version because early Brewdog IPA was a different ABV, so it's a different beer in their system. It's brewed by Brewdog. It's an Indian Pale Ale. It's from Scotland. The suggested serving glass is a shaker or a tulip, etc. So down here, there's a collection. This was a screen grab from quite a long time ago, actually, so there's only 324 ratings. Now that would be quite a lot higher. But you have a sort of average rating out of 5 and a few other details. If you scroll down the page, though, you get to these nice, well-considered reviews. So for instance, if I just read this top one here, it says, clear medium to dark yellow-orange color with a large frothy to creamy, good lacing, mostly to fully lasting off-white head. Aroma is moderate malty, caramel, moderate to heavy hoppy, citrus, dusty grass, orange-citrus, overripe orange-mandarin. Flavor is moderate to light heavy sweet and light moderate bitter with an average to long duration. Body is medium, texture is oily, carbonation is soft. And then there's a sort of weird date stamp machine tag that they've added. Additionally, there's 5 dimensions that it's rated on, so you've got a good quantitative rating that's more specific than just a sort of passing 1 out of 5. There's a aroma out of 10, an appearance out of 5, a taste out of 7, a palate out of 5, and an overall out of 20. And then that all is gathered together by the system to a 3.6. So you've got that times 400, and actually this is from, I think the screen grab is from almost 3 years ago, so I think it's more like a couple thousand reviews at this point of this beer, because that was Brewdog's ramped up quite a bit in popularity amongst this crowd. The crowd, I should sort of preface that one of the big problems with Rate Beer actually is that it's a fairly US biased community. So things that are harder to get access to in the States, you won't see as much activity around. So for instance, here's the Kernel Export Stout, a couple hundred reviews, very, very strongly rated, both in style and overall for the site. We've got some things. So if we look at the reviews for the Export Stout, we're going to pick at this a little bit. Has anybody, who in the room has had this beer? That's this one, the Kernel Export Stout. That's their big boy.
I've had a version of it. I'm not sure it's that specific one.
It's fine. I'm just curious. This is the rare crowd where it's possible it would be more than just me. You've got a bunch of descriptions like what we talked about before. So if we take all that text and we just look at the text sort of out of context and we concatenate it all together into a pile, we get something like this. And actually, this is not quite right. What we actually get is this, which is maybe not quite easy to read. So how we deal with that is clearly something we need to have a think about. And the reason we have to have a think about it is because lots of people write a lot of things about beer. So what we can do is turn to text processing to sort of have a think about how we can sort of suck out all of the adjectives and the nouns and give them some weight and some meaning. And specifically, we're going to look at something called natural language processing. And actually, in particular, even it's a subdomain within that, which is document summarization, and how we compare those documents once they're summarized. Document is a very loose thing here. It basically just means like a collection of text that we declare has semantic meaning as a unit. So for all the stuff I'm going to do from here on out, when I say document, I mean all the reviews of a single beer. That's a document. And there's lots of ways that I could have done that differently. I could take each review as a document. I'd get a slightly different thing. I could take a user's collection of reviews and call that a document for that user's opinions about beer or some such. Right, okay, so before we take all that text, we need to clean it up a little bit. So you may have noticed when I was reading that review earlier that there's a lot of like extraneous bits We don't want that. What we want is just the words, and even not all of the words. We don't want the thes and the a's and the ands because they aren't sort of contributing our understanding of what the beer is. They might just be telling us a little bit about the language background of the speaker or things like this. So we're going to start with something called tokenization, which is a really fancy word for splitting on white space. Splitting on white space. That's splitting on white space and lowercase and everything in Python for the people who don't speak Python. This is a slightly more complicated way to split on white space that uses a C library to do basically the exact same thing a little faster. The other thing we can do that's a little bit more complicated is we can say that we actually want to ignore words that are very common in the language we know the reviews are. So what we've done here is actually like narrowed the things that we can deal with sensibly. This is a less generic process. It assumes that it's English language. But it's more useful because every time we see a word like the, we just throw it out because it's not going to help. And this is like further in that category. So this is a really simple bit of Python. Don't worry if you don't know the Python. And all it does is it just checks if a word is an adjective or a noun. And it does this with a pretty simple sort of dictionary lookup. And if it's not an adjective or a noun, it throws it out. And the reason why we're doing this is because the particular thing we're looking to do is summarize what people are telling us about beer. So we want descriptors, and that's really all we want. Fine. So the first thing you can do is something called term frequency inverse document frequency, TF-IDF. And TF-IDF is a really simple way of taking a large document of text and reducing it to a small collection of words. And it works like this. So what we do is we do our whatever pre-processing we're going to do, and then for each document, we count the number of times a term appears in the document. And then for every document in our collection of documents, we count how many times it occurs in the document at all. So like the idea here is that what we have is a weighting that favors a word that appears a lot in a document, but not very often across all the documents. So if, for instance, if we're talking about beer reviews, hops, not actually going to have that high of a score because even if it occurs in every single review over and over and over again, it does that for every single beer. And so because it's common both in the document itself and also across all the documents, it doesn't get a high score. In contrast, if you see a word like rabbits, I'm guessing that's not used very often. So that one beer that reminds like everyone that drinks it of rabbits, which would be weird, is probably going to bubble up quite quickly. So you end up with a high weighting for that one beer that everyone describes as though it tasted of rabbits. Also, I don't know what beer that is, don't drink it. So if we look at a specific example, and in fact, we're going to go back to that export stout. All these words, if we run that TF-IDF across all the rate beer and specifically look at what bubbles up to the top of the export stout, we get words and weights. And so for the export stout against all the rate beer reviews, we see that the descriptors of it, coffee, chocolate, black, dark, licorice, espresso, cocoa, brown, bitter, smoke. That's nice. That's like concise. Those are good descriptors. And so I don't know, I'm a child of the early 80s, and so I see these pairs of like words and weights, and I want to do this. I just want to make a word cloud because it's like a warm blanket, right? So okay, so we've got this lovely data visualization that's straight out of 1999 or so, and it's nice. We feel like we've come somewhere, but the problem really here is that the computer is not clever, and so what it's done, this process, is it's taken all these things and it's there's actually like a lot of overlapping ideas here, right? So we have espresso and coffee, we have black, dark, brown, which are sort of ideas in the same vicinity. We've got cocoa and chocolate, right? So the way we can deal with this problem is something called topic modeling. And topic modeling is, it's from America. Topic modeling is the idea of understanding how concurrency can tell you about what words are similar to other words given a corpus. So like if cocoa and chocolate always appear in the same document, they probably mean the same thing. And so instead of this kind of simple process, we have to do a couple of things differently. So first, we take the pre-process and we count all the times the words occur together. And then after we've done that, we can take all of these times the words occur together, which we call topics, and process each of the documents with all of those topics. And I said earlier this is loose. That's a very loose explanation of how topic modeling works. So we do that, we get all these topics. The topics might look like this. So like here's a topic, this is again from the rate beer data. So this is one topic, these are the top 5 words in that topic. Chocolate, black, coffee, dark, roasted with some weights. Smoke, smoky, smoke, smoky, peat. Citrus, hop, grapefruit, orange, pine. This is like a particular kind of floral, or not floral, citrusy hop note. So once we have those topics, every beer becomes a mixture of topics, right? So we have this like abstraction layer that we've inserted in and we've worked out empirically from our corpus, so we can avoid these kind of overlap problems we had before. So the way we model this is something called Latent Dirichlet Allocation. I'll try not to be too heavy on this. So Dirichlets are a statistical model. Here's a nice idea of it. So you have a unit, and that unit has probabilities of emission. So the idea is that every time you have a bucket, and these are the balls in the bucket, and every time you kick the bucket, something comes out. And what color is that something? Well, 45% of the time it's blue, and 24% of the time it's pink, and 18% of the time it's black, and 13% of the time it's white. And that's a Dirichlet. And latent Dirichlet allocation is the idea that I do not know how many balls are in that bucket, and I'm going to guess in a reasonably informed way. And that's all the detail we're going to do on Dirichlets. So if we take all of that, and we go back to our kernel stout, and we go back to this massive pile of text, these are the top 4 topics for the export stout. So the thing that's really interesting about this to me is how different they are to the individual weights that we got from the words. And the reason makes sense, but you have to kind of stew on it a little bit. So the kernel export stout is a really, really dark, chewy beer with a massive hop load, despite the fact that it's labeled as an export stout. And so these 2 pieces are that. This is a texture comment that just got completely rolled away in the fact that there was so much cocoa and dark and bitter that the flavor or the words that described texture were just way down at the bottom, and so we just missed them entirely. And this is more of a dark brown to porter topic. And so what you have is this deep porter plus hops plus a really thick texture. And that's what this is telling us, right? So another thing that's fun about this kind of topic modeling is we can actually think about how people talk about the particular ingredients that are in beer, and indeed the particular processes that are in beer. So if we go back to this idea of water and malt and hops and yeast, we can pick out topics that observationally align with those particular things. So if we look at hops, here's a hops topic: citrus, hops, grapefruit, orange, pine. Here's a malt topic: caramel, amber, sweet, copper. Here's one that ties to yeast: banana, clove, bubblegum, bubble, gum. Do we have any fans of Hefeweizen in the room? So this flavor profile comes specifically from yeast, and it's there's chemicals that are produced by the yeast as an off flavor, and then water. So golden white, grassy, light head. So water is a hard one because the thing about water profiles in beer is that you notice when they're wrong, you don't notice when they're right. So it's kind of the absence of anything being terrible that is most water flavor profiles. This is very much a sort of Pilsner-y kind of topic, which is the closest we're going to get to a water-specific topic, really. Yeah. Okay, so let's examine the topic here. So I'm in the UK, so I expect that not everyone gets my joke, so I'm going to totally ruin it and explain it. So great taste, less filling. Does this ring any bells in the room? Yeah, just one. It's so much better than I thought. Okay, this is like a big marketing campaign from the US. It's a big marketing campaign of a really great beer called Miller Lite. So what we can do with all this is we can figure out what great taste is less filling. So let's look at the topics for Miller Lite, this fine beer from the US. So it is 50% that terrible watery topic. Literally, this is the 5th word in that topic, watery. That's just the data. 9% is this sort of grassy note, which is a pretty classic kind of rough Pilsner kind of topic. And then we have 7%, which is like a sort of nicer Pilsner idea. And then the last 5 is this kind of medium light sweet head thing that is a texture note that is not so bad. But like the top 2 topics in the reviews here are watery and white and grassy and golden. Delicious. Okay, so let's have a little epilogue. We've rushed through that in 20 minutes. There's a lot of things you can do once you've processed this data down this way, because effectively what we've done is we've said that we can talk about every beer as a ratio of 100 topics. I used 100 topics. You can actually sort of train to whatever you want. So that's a much smaller space than every single word in the English language. So we can do a lot of things. So for instance, let's look at this problem. My palate hasn't changed, your beer list has changed. Or indeed, I've gone on a trip to some other town, and so the beer that's available is different. So there's this idea of something called vector space models. Anybody in the room ever done anything with vector space models? Have a little bit? All right. Okay, one of you. So the basic idea is that you have a bag of words as points in some big dimensional space. So here's a toy example that I think is pretty easy to follow. So let's say that we have these 3 sentences in our concocted language. So this language has 2 words. One word is smiley sunglass face, and the other word is sad tear cat face. Those are the 2 words in our language. It's a very expressive language. So these are the 3 sentences we have in our corpus of sentences in this toy language. This one is a little bit more into the sunglasses, and then this one's pretty evenly split between some sad cats and sunglasses. This one, more of a sad cat thing going on. So what we can do using this vector space model idea, what we're going to do is we're going to count the number of times that each word occurs in each sentence. So this is 4 sunglass men and 4 sunglass people and 3 sad cats. And this is 4 of each. And this is 5 sad cats and 2 sunglass faces. And so we can put that into a vector space. Now, since there are only 2 words, conveniently enough, we can just put it in a 2-dimensional graph. So if you have more words, you just have more axes in the graph. More than 2 axes is very difficult to draw, but you can still do the math the exact same way. So here we've just taken our 3 sentences. I don't know how well it gets to the back, but this is sentence 1, this is sentence 2, and this is sentence 3. And this is simply the number of sad cats, and this is the number of sunglass faces. And so what we can do here is we can say sentences like sentence 1 is more similar to sentence 2 than sentence 3. And the reason we can say that is simply because the distance measured here is smaller here than it is there. And certainly these 2 are the farthest apart, right? So that's vector space models. We've taken something and we've sort of shoved it into a vector space. This idea of putting it on this graph, this is vector space. So we can do that with topics, where instead of having words on those axes, they're topics. And once we do that, we can ask questions like, what beers that are available in New York are similar to Kernel Export Stout? So you can work out what beer you should drink if you like Kernel Export Stout and you're traveling to New York, which is a problem that I have all the time. So we can achieve this by taking this vector space model and the data we've already generated and applying just a really simple geofilter to that metadata we had from rate beer. There's some Python, there's some more Python. I'm not going to talk about this too much. If you really want to look at my code, talk to me later. I'll hide it. And so after we do that, we get this nice list of other stouts that were produced in New York State that are available somewhere in New York City that are very similar in particular to Kernel Export Stout. I've had that one, and I can report they're both nice. So that's scientific, right? Great, and I'm going to stop there. I will happily take questions until we run out of them. Thanks very much.